To join two rails together, we use normally fish plates. And of course, one plate on this side and the other one on the other side. And the combination of the two rails and the two plates are held together with this kind of special bolts we use, and this drop-like thing here is in fact only to prevent the bolt from spinning while tightening. That's all. And these fish plates should look officially more or less like this one. Now, this is a prototype. There are still no holes in here, and normally here there's a cutout in the length. Now, luckily for me, I have also a little piece of prototype. It's way lighter and easier to show you how it should work. Here's a rail. Now, if you use your imagination, I'm not good in making drawings. And the fish plate should fit here on this little surface and here on this little surface. And then, of course, all the rest of the plate looks more or less like this. And goes through, of course, the hole for the bolt. Now, maybe you wonder, why am I holding here a prototype and not the original fish plate? Now, very simple. They don't exist anymore. For this type of rail, can't find anymore. But we found a workshop and they are willing to make them for us. So that's nice. And the only thing we need to do is to figure out the angle on this bottom side and the angle on this top side. Now, of course, the angle here and the angle here is important, because if it doesn't fit right, the rails will not sit right in length and width and height, and that will be a serious problem, maybe breaking or derail or whatevering. That's not good. And we gave some old fish plates that we don't use anymore because they were broken or bent or whatever. We gave them to this workshop, and they are unable to take the exact measurements. That's a problem. Which means that the Tram Association has to find the exact angle of this surface and also the exact angle of this surface and all other measurements, of course. And to figure it out, they chose me to volunteer for it. What I think is a little bit stressful, because if I get it wrong, if I give them the wrong measurements, the wrong dimensions, they will make 50 wrong fish plates. That's not the goal. Now, this piece of prototype thing they gave me, I don't think it's far off. Because here they made one angle 66 degrees and the other one 60. And if I put it in here like this, it fits more or less. And if I turn it around, it also fits more or less. So, I don't know. But I think the first thing to do is to take off all this rust, because taking measurements, precise measurements on rust, that doesn't work. So, let's give it a touch of wire brush. That's done, and I thought that after cleanup I would see things much clearer. But no, it's getting worse. If we have a closer look at this piece of rail, and I put my scale here, and I hope the camera will show it, but it is bent maybe see better on the other side. Taking measurements on a rail that's bent, that's not gonna work. But wait, there is more. This surface is of course the surface I need to install my fish plate on, like this. And I see that this one and the other side too, there is a lot, and I mean a lot of wear. And this is the bent rail. So this piece I cannot use. And the other piece I have here, there is a lot of rust pitting on this side and also on the other side. Which means there is no clean surface to sit on to take measurements. I think I start to understand why they chose me as a volunteer. Next problem is of course also make the drawing. Now, I'm not good in making drawings, I suppose you already know this, but what is easy to do is, for example, the angle, no problem. But if I give them this distance, that's not gonna work, because here and here there will be a round or a chamfer or something, which means the end point here doesn't exist anymore. So this side, not possible to measure. If I give them this dimension, that's also a problem, because taking measurements between two angled surfaces, that's not possible. Now, of course, you can put a scale on it and say that it's more or less, I don't know how much, but precise measurements, that's not gonna work. And then there is also, of course, the position of the hole where the bolt goes through. I can see clearly on the rail itself that this hole is not centered. But how am I gonna indicate the right distance between here or here or I don't know. Right, enough pretending that I'm thinking, but in fact doing nothing. I just cut off a piece of this long prototype and I will prototype a small one. I'm gonna use this one because of course this thickness is good, no problem. And I'm gonna use this one in the other direction, which means that normally these two little surfaces of course has to fit in here, and to prevent any confusion I will cut them off, make them square, both sides, and then use this piece in the other direction as I said. Let's go for it. A depth of cut of 1 millimeter and 160 strokes a minute. And this gives us a cutting speed of 22 meters per minute. And it leaves a really nice surface finish. That's good. Done, and I think now it looks again just like whatever piece of metal we should use to start with. But whatever. I also made a generous chamfer on both sides because this part is going to be manipulated by several people, and of course I don't want anyone to cut himself on this thing. Now the plan is now to make, first of all, this angle, the top one, because when I take the thing they made before, they note here 60-degree angle, and this one 66. The 66 isn't far off, but it's not correct. But when I fit it in here, the 60-degree on top could well be exactly what you need. So over to the milling machine and then cut one side 60-degree, and for the other side we'll see later. And to cut the angle, I will do it here on the milling machine, and I will tilt the head. Of course I can also tilt the table and tilt whatever I want, but I think the head is the easiest way, because here I have this graduation, nice and big numbers. And why not hand feed a little bit? It's easy to use. Of course I can also cut the angles here on the shaper. Tilt the head. These numbers here on this side, they are really easy to read and also really accurate, very precise. But at 160 strokes a minute, holding my hand on a moving ram, that's not really easy. Which means the milling machine, it will be. And because I will cut in this direction, of course I have also to tilt the vise 90 degrees. And in one slot, it's very easy. I can use the official T-bolt, but on the other side, I will need to install my clamp, or maybe two. Since I own this milling machine for a few years now, I think this is now the second time this happens to me. Almost unique. I just throw this vise on, and then I tighten very loosely this bolt here, not too tight, and then I put my clamps not too tight, and I check with the indicator, and it is square at less than 1/100th. I think I should buy a lottery ticket. Right, vise is tightened down and double checked. And now let's set this thing at 60 degrees, which is of course 30 degrees to make it easy. And what's nice is that the 30 degrees is just right here in front of me. That's easy. I'm checking my not good prototype here. And what I would like to do on my it's gonna be good prototype is of course to cut this surface but in one go. And I have here an 18mm 2-flute end mill, and I think it's just gonna work. Let's try. This cutter works but it sounds really violent. And also, let's give it some oil. It's spitting oil all over the place, and also it smokes. That's not good. And this should be it, or more or less. What I think I'm gonna do, I'm gonna set the head back square and cut a tiny little flat surface on top here. And that will serve me to resistor on the other side, so I'm sure that the other side will be parallel with this side. Let's do. Finished, deburred and ready to do a test fit. That of course I already did. And I found out that if I touch this surface and leave it stick out here, camera can see it a little bit, yes. I see that angle is close, but not perfect. And on the other side, same. And when I take the thing that this workshop made, it gives about the same results. So I think the angle must be a little bit steeper. I'm gonna try, instead of 60, I will cut it at 58 and see what happens. Now of course 58, because I did a little bit of testing with I figure out the angle device here. "58 degrees. The first one was 60. 58. Nope. I think I just made a stupid mistake. Instead of give it 58, it looks more like it needed 62. That's also 2 degrees of difference, but in the other direction. Right, off camera I will cut it again and bring you back here when it's done. And it is done, and now it is at 62 degrees. And I think we're getting somewhere. When I put it on the rail here and I feel this surface, because you cannot really see it when you feel it, and I check between two, it looks more or less parallel. And the other side too. That's good. Now that I know that this 62 degrees seems to be correct, or more or less, of course I continue figuring out the other angle here. And I put my part exactly where it has to be, and then I made a little line here. And I check with, oops, it's heavy. I check also with this one and with the figure out the angle device, and it could well be that the angle here I need is also 62 degrees. So it's gonna be a little bit trial and error method. I'm gonna cut this one at 62 and see what happens. I took it out of the machine and left it, on purpose of course, a tiny bit oversized, just to be able to check. So now here it looks parallel. This angle looks good. Of course there's too much stick out, and here too. But what the most important is this angle here, this little part. And I hope the camera shows it, but it doesn't look bad. Maybe if I move a little bit this future spacer bar here. Alright. I'm gonna continue, take a little bit more off on this side and a little bit more here, because this corner needs to fall 2 or 3 millimeters above this one. Let's do. Before cutting this surface a little bit deeper, I first gave it a touch of shaper to make a flat head. And I think it was a really good idea. Because, as you can see, it seems to fit. Now, what I think I'm gonna do is to make them symmetric. I'm gonna cut this little surface. Keep it a bit closer, this surface a tiny bit larger, deeper, bigger, and I will make the same on the other side. And because both angles here and here are also the same, the thing will be symmetric. Let's see if it works. Right, let's do the same on the other side. Same, symmetric, and it fits. I think we can call this success. So I suppose all that's left to do now is to drill the hole at the right spot in here, of course, for the bolt. And just to have an idea of the position, I draw it all out here. So now I can measure and then center the thing. Right here. A hole. And this should be the finished product. I don't know if you can see, but I marked here with letters 62 degrees on both sides and a little Sharpie arrow. I think I'm gonna cut it in with a chisel. And now the test. It seems to fit. Now this is of course the rail with the slight bend in it and a lot of wear. But as you can see, and I hope you can see, the fit here is almost perfect. I have here stick out of 1 or 2 millimeters, so that's good. And this surface sits very well on the rail angled surface. Which means that my job here and now is finished. Now, what's gonna happen next? Instead of making some kind of drawing that no one can read or no one can figure out how to take measurements, I think I'm gonna give this part to our local specialist. In the association we have a person, and he's a professional railroad worker, building, making things. A real one. And he will give this thing to the workshop. And then they will figure it out.